Okay, so let's continue to today's workshop. So following the lectures, you probably have a better insight into the rationale why we want to differentiate insomnia and sleep apnea just using questionnaires. And so I think in this way you have a better idea that this problem is really close to our real world challenges in the everyday practice. So let's get into our data. So today's data will be just from is the identified and the delinked the data from the real patients. So I want to emphasize that I will not release this data outside the classroom. So I hope you just use this data for the education purpose, because even we make this data de-identified and there's absolutely no age and sex information, and there's no other identifiable information in this data. But still, I still need to emphasize that the data cannot be released outside the classroom. So the data will be strictly used within the class, and as even though it's just a questionnaire data. So I think for most AI studies, we will need to follow this principle, because we for the purpose of the AI studies, usually the hospital will collect a large amount of the clinical database. And usually this database has to be linked and de-identified before they can be implemented for the research purpose. So I think we need to follow these ethical principles. Okay. Okay, so let's look at the data here. So for the PSQI data sets, we will have a polysomnograph verified diagnosis about this patient. For what I mean is that we will collect the questionnaire data before they underwent polysomnograph studies. But after that polysomnograph studies, we will make a final diagnosis, which is based on the PSG data. So for example, if these patients have PSQI data, but they finally verified as they have sleep problems, but they do not have any other physiological sleep disorders, then we will make a diagnosis of primary insomnia here. And likewise, if the patient have sleep complaints, then also verified by PSG to have sleep apnea, then we will have a diagnosis of sleep apnea here. So in the first column is the ground truth about these patients, whether this patient has a primary insomnia or sleep apnea. So in this data, we will try to differentiate 100 patients with primary insomnia and 100 patients with sleep apnea. So again, there's no demographic information in this data set. So I'll just make sure this data will be totally de-identified and delinked. Okay. So for the other part of the data, you can see there's different questions from 5.1, 5.2 to 5.10. It is just corresponding to the PSQI questions. And we will convert these questions to, including the first 4 questions, and to the sleep quality, sleep latency, durations, efficiency, likewise, etc. So these data will give us an overview of the the analysis, and we will try to build an AI model to differentiate these two disorders just based on these numbers. Okay, so the first thing we need to do here is try to read the data into the MATLAB. So in this case, we just use read table functions as usual. We will input the command data equals to read table, and the input file name is sleep questionnaire datasets dot xlsx. And you will probably see this warning message when you execute this command. You will see it reads the table variable names were modified to make them valid MATLAB identifier. This is because when you look at the original table, it is opened up by the Excel. You will see there's a space here. And in the MATLAB, we need to make a variable name without space. So that's why the MATLAB will automatically insert an underscore here to make sure there's no space in the variable name. So it will give you a warning message, but don't worry about that. So the MATLAB will do this for you. Okay. So the task we will explore today is that we will want to do the classifications. But before that, I still want to show you the difference between classifications and regression. So in the previous lectures and workshop, I already showed you lots of regression examples. For example, we will use the brain volumes to predict the brain age, or we will use the insurance, the demographic data like a BMI or the age or number of children to predict the premiums of insurance plans. So that is the regression problems. But in the last week, we introduced about how to classify different chronic kidney disease or those without. So that is a classification problems. So same as the last week, today's task is also a classification problems. In that problem, we will try to make a line to separate two or more groups. So that is a very intuitive graph, show you what's the difference between a classification and regression. In the regression, we will use some data to predict the outcome. And that outcome would be the ordinal or continuous variables. But in the classification problems, the outcome will be categorical variables or nominal variables. Okay, so I think so far we have already introduced about regression and the decision tree, and maybe a little bit about the support vector machine, but we didn't practice this in the previous workshop. So of course, then we will have a neural network models that can also do the classification task. But I will leave this into the later half of the course. And so today, I think we will focus on the logistic regression and the support vector machine. And I think you already have the decision tree course last week, so you can also try yourself on this data using the decision tree models. So with this practice, then you will have a more complete idea how to do the machine learning in different types of the data. Okay, so in the previous workshop, our regression task is to use the linear model. So this is quite a linear straight line regression here. And if we have a data like this, it just have a 0 and 1, okay? You have only two states here. Then if you just apply the linear model, you will just try to plot a line to cut across these two groups. But obviously, it's not very useful because a straight line cannot have a very low accuracy in separating these two groups of the dots. Okay, so that's why in these binary classifications, we will typically use the logistic regressions. And logistic functions is a function that can simulate or emulate these binary categorical data. So you are just like this sigmoid curve, then the probability of the logistic function will increase sharply around the middle line and to the another states. So this is very useful and very commonly seen methods in the machine learning. Okay, so just like the regression, the difference between logistic regression and the linear regression is that in the linear regression we use linear functions, straight line functions to predict the outcome based on the predictors. But for the logistic regression, we use the logistic functions. So in the MATLAB, we can use a generalized linear regression model to do the logistic regressions. So this general linear regression model can also do the linear regression, but here I want to use this for the logistic regressions. So now we try to prepare our data. So when you read the data into MATLAB using a table format, and for some MATLAB functions, just what I showed you in the previous course, you can just type a very simple command. For example, you can designate the response variables, and the model will handle the resting for you. But I think MATLAB has some inconsistency here. So for some functions, they have different input format. So for example, the generalized linear model, the Ph.D here, they require two input variables. One is the predictors, and the other is response. And you need to make these two variables not in the table format, but only in numerical and nominal categorical format. So that's why we need to first put two lines here to transform the data into acceptable format for the Ph.D functions. So for the predictors, it's from the second column to the last column. So remember, in our data, from the second to the last column is the PSQI data. And the first column is our ground truth. So you can also designate as a response. Okay? So the predictors includes around 18 variables. And we use table to array to convert the table format to the numerical format. And for the categorical variables, like a diagnosis variable here, is either PI or SA, which represent the primary insomnia and sleep apnea, respectively. But for the MATLAB, we cannot just use these as the input. We need to categorize these variables. So that's why in the second line, we use the categorical function to convert the PSG diagnosis information into the categorical variable. So after we pre-process these two informations from our data, then we can input these predictors and response into the Fitzgerald model. And the important thing here is that we need to specify the link function here. So remember, I said the difference between logistic regression and linear regression is that in the case of linear regression, it's a linear line functions. And for the logistic regression, we use the logit function here. So we need to specify the logit as our link functions. And we also need to specify the outcome is the binomial variable, which is the binary classifications. So the distribution parameters we will use the binomial, which means the binary classifications in our models. Okay, so once we use the correct parameters, then we can input all this information into the Fitzgerald M. Then we can derive our model here. So you can see the results of the model when you just type yourself in the MATLAB. And you will come up with a big table here. And the first thing it will show you the generalized linear model is linked by the logit functions. And we have the variable name from x1 to x18, but we will discard the rest of them because the reason is because I didn't normalize the rest of the data. I just used the first 10 data as is meaningful predictors. So, but no worries, doesn't matter because the MATLAB already processed find the problems and ignore the rest part of the data. Okay, but for here, you will probably look at the p-value for each predictors. For example, here, if we set the alpha at 0.05, then we will see that there are three variables are very significant, which is x3, x4, and x5, and also x8. Sorry, the four variables. So let's remember these orders: x3, x4, x5, and x8. Okay, so if you look up these corresponding questions in PSQL, you will immediately have insights why this question can differentiate insomnia and sleep apnea. So for example, the question 3, 4, 5 are these questions. The third question is that have to get up to use bathroom. The fourth question is that cannot breathe comfortably. And the fifth question is cough or snore loudly. And also, the eighth question is have bad dreams. So immediately you will see that these questions are important to differentiate the primary insomnia and the sleep apnea. So let's get back to our logistic regression tables. So here, the sign of the t-test is an indicator of the direction of the correlations. For example, the positive t means that we will have a larger the prediction toward the larger values of the group. So in this case, because we designate the primary insomnia as 1 and the sleep apnea as 1 and the primary insomnia as 0. So the positive t-test means the positive correlation between these questionnaire values and the presence of sleep apnea. And in contrast, the negative t means a negative correlation between these question scores and the presence of sleep apnea. So the negative association means that this is more about the primary insomnia. So Now you should have more clear idea because the question 3, 4, 5 are all related to sleep apnea. So you will understand that cannot breathe comfortably or cough or snore loudly, of course, is related to the breathing problems. But oftentimes, the get up to use bathroom is the long-term side effect of the sleep apnea. It will cause in the urine the difficulty problems. Okay, so the CDE is very meaningful in differentiating sleep apnea, but the 8 questions that have bad dreams is really about insomnia. So that is we can use this model to identify classify the sleep apnea and insomnia. Now you probably will be wondering, then if we know these questions, then we already have a model. Can we evaluate the accuracy of this model? Okay, so that is a very important part of the machine learning. In the case of the regression, then we can only evaluate the difference between the actual outcome and the predicted values. So in the case of the regression, that outcome can be continuous variables. So we can only evaluate the root mean square error or other metrics to evaluate the fitness of the model. But in a classification task, we will have a very clear number of the correction classification and those without correct classifications. So that's why we need to evaluate this trend model using a very unique, and we also use many statistics to describe the performance of these classification models. So the first thing we need to do is we try to output the predict status of this model. So same with the previous course, we use the predict functions to input the predictors using into this model, and we'll output the predicted values. So in the first glance, you probably will you'll feel confused about the result. For example, the result should be 1 or 0, but in this case, we will see a number between 0 and 1. So remember, we use the logistic regression to regress the 0 and 1, the two groups. So it's very intuitively that the output will be based on this logistic regression, which will result in a continuous variables. But the vertical line will be horizontal line will be around the 0.5, which means that if the output value is below 0.5, we will consider it as the zero state. And if the value is above 0.5, we will think this is the number 1 state. So in this case, the number 1 represents the primary insomnia. So the number 1 represents the sleep apnea, and the number 0 represents the sleep apnea. So here you can see that for these 200 cases, most of the first 100 cases will be below the 0.5 because they are all classified as the primary insomnia. But if you look into the later 100 cases, then you will see most of cases are above the 0.5, which is represent in the sleep apnea. So this is the very simple explanation for what we are going to do with the Y prediction, because we cannot use this data to calculate the number of the correct classification. However, we can consider this as a probability. It means that is there high probability of the case to be the sleep apnea? For example, in this case, it may have only 22% of probability to be diagnosing sleep apnea, but for this case, it indicates that it has 73% of probability to diagnose sleep apnea. Okay, but to calculate the number of the correct or incorrect classifications, we need to convert these continuous variables into the binary variables just based on 0.5 threshold. So the first thing we need to do is that we convert these Y predict to be binary classifications using a threshold of 0.5. If the Y predict is larger or equal to 0.5, the results will be 1, and otherwise the results will be 0. And we also, because the results of this first line is the logical variable, so we need to convert this to the double format. That is because for this format we can do many calculations. And also for the response variables, we want to convert to 0 and 1. So these two lines are just try to make the ground truth of the table, which the first 100 cases are primary insomnia, and the later 100 cases are sleep apnea. We just convert this PI to be 0 and the SA to be number 1. Okay, so let's get back to this slide. And so for the first 4 lines here, then we will just complete our pre-processing of the outcome data. Then we will input this outcome data, including the predicted values and also the ground truth, into the confusion mat, the functions. Then we will plot the confusion chart here. So if you do this in your MATLAB, you should be able to see this confusion matrix. And this confusion matrix, the one axis is the predicted class, the other is the true class. So it means that for those diagnoses with primary insomnia, there are 76 cases is also being diagnosed as a primary insomnia. But at the meantime, there are also 24 cases has been put into the wrong diagnosis, is being diagnosed as sleep apnea. And likewise, there are 81 patients being diagnosed as sleep apnea is correct classifications, but there are still 19 patients who just missed these patients and think that they have only primary insomnia. So this is the basic ideas of the confusion matrix. It's a 2x2 contingency table, and ideally we should see a model that can have a nearly 100 number in these regions and also nearly 100 number in this region. Means that most cases have correct classifications, and only a few cases have a wrong classification. So in this case, you will probably have a very intuitive idea that how do we calculate the accuracy or sensitivity or specificity. Okay, so these slides will give you a very concise overview of this matrix. So for the accuracy is that you try to add up the total correct classifications, which means the Tn plus Tp. That is true. The correct classifications in our case is the number 76 plus the number 81. And those are the cases we have correct classifications and divided by the total cases. So in our case, our accuracy is a 76 plus 81, which is the 157, and divided by the 200. So the accuracy was around the 75%. Okay, so it's very easy to understand the concept of the accuracy, because you need to add up all correct classifications, whether it is the classified for each groups. Okay, and for the precision, we will look into these columns, which we try to make sure our classification are in a precise way. As remember the slides I present in the previous course, the precision means that each time of the test will result in a narrow bias, and there's low the low variance. Okay, the precision means the low variance. The accuracy means the low bias. So in the case of precision, we will calculate the number of the true positive divided by the false positive and the number of the true positive. Okay, so if the number is higher, then we will see that this has a higher rate of the true positive classifications. Means in our case, we'll see that there's more number in the classification of the sleep apnea compared to those without. Okay, and the sensitivity and specificity is kind of similar, but is look into different columns and rows. So for the sensitivity, we look those with have a certain state. And usually I would say that sensitivity is about how to evaluate how many cases you can identify in all patients. Okay, so for example, how many patients with sleep apnea can we identify with our AI model? That is the sensitivity. And for the specificity is that how many, usually we will say this, how many healthy persons will be evaluated as a healthy by our model. So in our case is that how many cases of the primary insomnia will be diagnosed as a primary insomnia in our AI model. So the sensitivity and specificity is the kind of the opposite things. And usually we will need to find a model to have a balanced sensitivity and specificity. Okay, so usually we will have a binary classification between healthy and patients. But our case here is quite unique because we already know that they are patients because they have sleep complaints. Otherwise, they will not come to our hospital. And because they have sleep complaints, then they are basically they are all patients. Then in that case, we want to classify whether they have apnea or insomnia. So that is the difference between our data and these slides. Okay, so this is a very basic statistics you need to know about the confusion matrix. And of course, and there are more metrics that you can evaluate. So I encourage you to to click this link and also the reference link I provided in the last slides. So you can try to study what is the, like for example, what is F1 score and what is the positive prediction rate or something else. Okay, so but for now, we will just try to evaluate accuracy, precision, sensitivity, and specificity. But I still encourage you to study other metrics so you will have more insights how to do machine learning. So for this part, I will provide you a simple script. And this simple script will calculate the confusion matrix statistics data just based on the input predict values and actual ground truth values. And for this, we have accuracy, sensitivity, specificity, precision, recall, F-score, and the other things. And I still encourage you to look into these definitions. And here you can see that there are two values here. That because it's just based on which one is the label 1 or which one is the label 0. So you have two values here, but I still encourage you to follow the definition here to derive the correct answers, not just using these confusion stats functions. Okay, so I think for now, then you have some ideas about the sensitivity and specificity and accuracy. And usually we'll evaluate the model by this kind of the curve or representations. This technique or method is called receiver operating characteristics. And oftentimes we will call this ROC curve. So ROC curve is a curve try to evaluate the balance between the sensitivity and specificity. So like I said, if you have a test with a very high sensitivity, it means that you will you have a very high chance to catch those patients. But if you have a very low specificity, then at the meantime, if you have a very low specificity but high sensitivity, then it means that you have a large portion of the results are false positive, or it just means that you misclassify the normal people to have a disease. Okay, and in contrast, if you have a test with a very high specificity but low sensitivity, that means that the test will not catch a patient, but will catch those normal people. But you will also have a chance to misclassify the patients to be normal. So that is the difference between the sensitivity and specificity. So if you understand those parts, then you will have an intuition that usually the sensitivity and specificity have a balance. We need to find the perfect scale here to have a 100% sensitivity and also 100% of the specificity. And if the ROC curve show us this kind of scale, we want this curve to close to the left upper corner as close as possible. If you have a ROC curve around this one, and I think it's quite a good result, because most of the real world data will have this kind of classification results. And if the ROC curve is on a diagonal line, means that you have the technique has no ability to differentiate these two states. For example, if we have our results on a diagonal line in our data, it means that the model cannot differentiate sleep apnea or primary insomnia. And also, if you have a RC curve in the lower part of the corner, then it means that it's even worse than gas. Okay, so it's just forget this model. We want this model to be as close to this left upper corner. And likewise, in the precision recall curve plot is very similar, just like a different direction. Usually, we will use these representations to make ROC curve. So to do this is a little bit tricky because for our model, it already have the predicted results. However, to do the ROC curve, we need to evaluate the model in the different regression results. Means that every regression result has a certain error. So in that range of the error, we want to know that what's the performance of our model in different error conditions. So that's why we will to output evaluate the model with the fitted probability, and use that information. We can compare this probability with our ground truth to derive the ROC curve using the perfect curve functions. So you can look up into this function and to study how to do the ROC curve in your own data. But in our case, I will just show you that if we already have a model here, then we can use the fitted probability to output the ROC curve, and we can just simply plot x, y, and designate the false positive and true positive, and we can see our result here. So our ROC curve here is quite similar to this one, which has a skillful classifier, and the area under curve is not bad. It's around more than 0.80. So that means that we have quite a good model to differentiate the primary insomnia and the sleep apnea. Although the accuracy is around 75%, but you can see that ROC curve, it's not bad actually. Okay, so this is the results of the logistic regression. So I want to take a brief stop and try to think all of this, and to make sure you understand every part of our calculations. And so this part is very important because you need to know how to evaluate your model. And so this is, remember in the first workshop, I show you that a general principle of the machine learning is that you need to pre-process your data, and then you need to decide a model. You need to divide the data into the training and the testing, and need to evaluate the performance of the model in the training, and also use that model to predict outcome or response in the testing data. Then you evaluate the performance of model in the testing data. So today, because of the time limitation, because I still want to show you how to do the support vector machine, so I didn't show you how to divide the data into training and testing, but the principle of splitting the data is same as the what I showed you in the previous workshop. So you can try yourself using the previous codes to divide the data into the training and the testing, and try to see if there is any difference between the model performance between the training and testing data. Okay, so this is the logistic regression. Okay, so let's get into some fancy part of the machine learning. So you probably have heard about the support vector machine. And these names are fancy, but actually the principle behind this SVM method is quite simple. So for example, here we have a binary categorical data here. So naturally we will do the binary classification. We want to, intuitively, we want to draw a line to separate these two groups. And for the L1, of course, you can see that it doesn't perform very well because it just cut across the blue dots, and it cannot differentiate the blue dots from the red dots. It has a high errors or bias. And for the L2, then it seems that although it can separate the blue and red dots, but somehow it is too close to the blue dots than the red dots. So it's still L2 is not optimal solutions. And so for here, L3 is our optimal solutions because not only it can separate the blue dots and the red dots, but also it has roughly equal distance to blue and red dots. So the L3 is our optimal solution. And the support vector machine is an algorithm to find this kind of solutions. So it will determine a decision boundary that has optimal the results. So that is the whole idea about the support vector machine. And this is a simple case. And if our data is not linear, of course, you can try to determine the decision boundary as a curve. That is no problem with SVM. So SVM is quite a useful technique until the development of deep learning, because SVM is a nonlinear technique try to differentiate the boundary in the nonlinear data. So that is one of the important methods we need to know in the machine learning. So for the SVM, we simply use the fit CSVM functions to derive our model. So in this case, we simply need to input the table as a data here and to specify the response variable. And in our table, the response variable is PSG diagnosis. You will just delete the space here to make sure there's no space in our variable. And so we call this model 1 in contrast of the model we used for the logistic regression. Okay, so if you type the first line here and execute the first line, you should be able to see the model 1. And the model 1, unlike the logistic regression, when you can directly evaluate the p-value and t-statistics of the model, in the support vector machine, it's not very straightforward to see which variables are significant contributors or predictors of the outcome. So that's why I didn't show you the results of the fit CSVM here, but I encourage you to try yourself to see, just delete the semicolon here and to see what's the inside this model 1. Okay, but the rest of things are very similar because we can still use predict functions to generate the output of the predictions based on the predictors. And then also we will try to organize the data into a numerical format of the ground truth and also the output of the predictions. Okay, so and so for this way we can also calculate the confusion matrix as a C1. So in distinction to the C we used for logistic regression. Then we can plot the confusion chart here, and also to calculate the confusion statistics for this data. Okay, so let's see the results directly here. So using the support vector machine, then probably the results are quite similar to those previous one using logistic regression. So remember in the previous one, we have around, let me see, 76 primary insomnia to have a correct classifications, and 81 to be correctly classified as sleep apnea, 76 and 81. And here in support vector machine, we still have 76, but only 80, just minor decrease in performance using SVM. So it seems that SVM has a very similar performance with logistic regression. And so in this case, we have generally the same result. So you'll probably be wondering that is that normal? I will say that it's quite common when you do your own data. You will find that usually the regression will give you a good results already. And these nonlinear machine learning methods, sometimes they will just perform roughly the same or a little bit superior to the regression results. So that's why I need to emphasize that when you do the AI in your data, just don't forget the regression methods, because not only it has a very good interpretability, but also it has a kind of average performance in every real-world data. So here, when you want to calculate accuracy, you simply add 76 and 80 divided by the 200. So we will have accuracy around 78. Okay, so that is not bad, and the performance is also similar to the. Okay, so based on this support vector machine, we will still want to derive the ROC curve, but the process is a little bit different with what we are doing in the logistic regression. So the codes are a little bit different. So just for the support vector machine, we need to find the posterior probabilities, which means that we want to find out the probabilities to predict it by this model. And use this probability, then we can derive the information we need for plot ROC curve. So there are a little bit difference in the coding of the to processing this ROC curve data, but the rest of the codes are the same. So you can just plot X, Y, and give the correct labels and titles. And the title this here is by support vector machine. You can see the results of the ROC curve by support vector machine is very similar to what you have seen in results by the logistic regression. So it means that in this case, the performance of the support vector machine is quite similar to those by the logistic regression. If I am the developer of AI model, then I will decide I will use the logistic regression, because in that case, logistic regression can give me more meaningful interpretation. Okay, so just give you some brief reference here. So I think in the data we explored in the past 2 months, then we always use a balanced data. The balance means that we have an equal number of the group of the data. For example, equal number of subjects in each group. For example, in case of the brain sex classifications, then we have equal number between the male and female. And in this case, we have equal number of the patients with primary insomnia and also equal number of the patient with sleep apnea. So what if you have a different number of subjects in each group? And that is the problem with the imbalanced binary classifications. And in that imbalanced binary classifications, you will have a matrix. For example, if you want to evaluate the sensitivity, and because you have more patients than the normal healthy persons, then probably you will have a result with a very high sensitivity. This is very naturally, because if you have more patients than the healthy persons, then it's easier to find the patients than the healthy ones. So you have a high sensitivity results. So that is this flow chart will help you to evaluate your model when you have imbalanced binary classifications. So I encourage you to look into the explanation of this graph figure and to have a better idea than how to choose your performance metrics when you have imbalanced data. So finally, I give you 3 online references here. Then these online references, which is I already just verify that I think these are very useful and very clean information that you can try to study what is the classification task and what's behind the, for example, what's behind the rationale behind the logistic regressions, and also the support vector machine and other methods. So this workshop will conclude our first part of the course, and I hope you through this course you already have some insights about the machine learning and already explore different kind of data sets, and most importantly, I hope you already familiar with how to do this kind of tests using MATLAB. So if you already learn MATLAB, you will find that it's easier to learn the Python and R, because MATLAB is quite a simple programming language that you can do many things. So hope you enjoy this workshop, and I will see you next week in person to let's take a look into our presentation 1, case presentation 1, using the brain cells classification task. Okay, so see you later. Bye bye.